I'll start by using the average value of each feature as a first guess for any missing data points. That's what mean means in this context. Think of it as a reasonable starting point before I refine my guesses. This is one of the features in our dataset. I'll use this, in this context, to help predict the values of features B and C. Let's just focus on that. The other features depend on it. I'll impute the missing values for the features in order. First, I handle feature A, then feature B, then C. This is important because the later features depend on the earlier ones. I'll use regression models, like linear regression, to predict missing values. It's not a one-shot deal. Instead, I'll create a model for each feature, and repeatedly refine the estimates based on the latest available data. This is where the iterative in the name comes from. This feature depends on feature A, so, after I've imputed A, I use the imputed values to help predict B. This is my iterative process in action. This is the overall process of filling in the missing data in a dataset. The term iterative means that I'll repeat the process multiple times until my predictions become stable or I reach a predefined stopping criterion. The imputer part means it's the thing that fills in the gaps. It's a bit like solving a puzzle iteratively, where each step is based on the results of the previous step. These are the final values that I've calculated for the missing data points, after completing all the iterations. These are my best estimates based on the available information and the relationships between the features. I'll use the average of the existing B values as a starting point for filling in any missing B values. This is because I've set the "initial underscore strategy" to mean. This is the first step before the iterative process begins. Because C depends on B and IterativeImputer works step by step, when I estimate missing C values, I use any B values I've already filled in. It's like a chain reaction. I fill in B, then use those improved B values to improve my estimates for C. Nope. The order isn't random. I follow the exact order of the columns you give me. This is a multiple choice question testing understanding of how the IterativeImputer in Scikit-learn handles missing data, particularly when features have complex relationships. I'll need to carefully analyze how "initial underscore strategy" and feature dependencies affect the imputation process. I'm going to evaluate each statement individually to determine if it's true or false based on my understanding of the algorithm. This statement checks my understanding of the "initial underscore strategy" parameter. I know that "initial underscore strategy" equals mean sets the initial values to the mean. Therefore, this statement is true for feature B. This statement tests whether I understand the iterative nature of IterativeImputer. Since feature C depends on B, the algorithm will improve the accuracy of C imputation by using any already imputed values for B. This makes statement B true. This tests my understanding of how sensitive the results are to the choice of "initial underscore strategy". While using median instead of mean might change the imputed values, there's no guarantee of a significant difference. It depends on the dataset, the distribution of values, and presence of outliers. The statement is too strong and is false. I'll explain how Scikit-learn's IterativeImputer works. It's an iterative process, meaning it refines its guesses over multiple rounds. It's like solving a puzzle. You start with some initial guesses, then use those guesses to improve your understanding of the puzzle and get better guesses. The process continues until your guesses stabilize or reach a certain level of accuracy. We're working with a dataset containing 3 features, A, B, and C. This is important because the relationships between these features drive the imputation process. For example, one feature's values might depend on another feature, impacting how we fill in any missing data. Before the iterative process starts, we're choosing to use the average, mean, of each feature to fill in any initial missing values. It's like making an educated guess based on what the average values are for each feature. It's a starting point, and later iterations will refine the results. The relationships between features A, B, and C are crucial. Think of it as a chain reaction. Feature B's values depend on feature A's values. Then feature C's values, in turn, depend on B's values. This chain of dependencies affects how the imputation will work. Filling in missing data for B will need to account for A. Similarly, filling in missing data for C will need to consider both A and B. Here, I will start by using the average value of feature B. Then I'll use a regression model that uses values from feature A to create a better estimate for any missing values in feature B. I am refining my guess. Now I am moving to feature C. I'll start by using its average to fill in initial missing values, but because C depends on B, I'll then use a regression model that considers feature B to improve the estimate. Because the imputation of feature B has already been done, this process will leverage those improved estimates from B to further improve the estimates for C. This is a single round of the iterative process. I just filled in the missing values for features B and C. I am now repeating this process again and again. After many rounds of the iterative process, we get a new dataset where the missing values have been filled in using the refined estimates that I improved over each round. It's important to note that this final dataset will be more accurate and less biased than the dataset we started with. If there were missing values in feature A, I would have started the iterative process by dealing with those values first, using its mean as a starting point and then refining the estimates with subsequent iterations. However, this is optional based on whether any missing values existed in the feature A. We're working with a dataset that has 3 features, A, B, and C. I'll be focusing on how these features relate to each other during the imputation process. The iterative imputer starts by using the mean, average, of each feature as its initial guess for any missing values. For features B and C, this is our starting point. Think of it like making an initial educated guess before refining it using more data. I'm starting by imputing missing values in feature B. To do so, I use the mean of the non-missing values of B as my initial guess. This makes sense because I am starting the iterative process, and this is my best starting point. Now that I have imputed values for B, I move on to impute missing values in feature C. Importantly, I use the already imputed values from B and feature A to refine my predictions. This makes the process iterative. The results from one step influence the next, leading to better estimates. Features have dependencies. B depends on A, and C depends on both A and B. This means the value of B is influenced by A, and C is influenced by both A and B. These dependencies are key to how the iterative imputation works. Scikit-learn's IterativeImputer uses regression models to estimate missing values. It does this in an iterative way. It makes an initial guess, then refines that guess by taking into account the dependencies between the features. This process repeats until the imputations converge or reach a defined maximum number of iterations. We see this as the overall process. Scikit-learn's IterativeImputer works in a series of steps, repeatedly refining its guesses until it's happy with the results. It's like solving a puzzle. You make an initial guess, then use that to improve your next guess, and so on. We start by using the average, the mean, of each feature's known values as a first guess for any missing data. It's a simple, sensible starting point. Think of it as your initial roadmap. If feature A has missing values, I will fill those initially using the strategy you've set in step 3, mean, median, etc. This step lays the groundwork for the next features. It sets the stage for the next phase. Now, I'll tackle feature B. Since feature B depends on feature A, I'll use the imputed values of feature A to predict the missing values in feature B. It's like building a house. You need a foundation, feature A, before constructing the walls, feature B. I'll repeat the process for feature C, using the values already imputed in features A and B to get an even better estimate for missing values. The more information, the better the predictions. This is like adding the roof, feature C, after the walls are up. After filling the holes in the first round, I do it again and again, improving the imputations with each pass. That's the iterative part, continually refining the results. It's like polishing a gem until it shines. Finally, I'll have a complete dataset with no more missing values. The imputed values are the best estimates I can make given the data and relationships between the features. It's the final, refined product of all the steps. This notation shows how the features rely on one another. For example, B to A, means B's values depend on A, so I'll use imputed values from A to predict the missing values in B. This order is important for getting accurate results. It's all about the dependencies and order of operations. I'll explain how scikit-learn's IterativeImputer works. It's a method to fill in missing data points in your dataset by using an iterative approach, which means it refines its guesses repeatedly. We have a dataset with 3 features, A, B, and C. Crucially, B depends on A, and C depends on B. This dependency is key to understanding how the iterative imputation will proceed. Before the iterative process begins, IterativeImputer needs an initial guess for the missing values. Here, that initial guess is the mean, average, of the existing data for each feature. First, IterativeImputer will tackle feature B. It uses the mean of the existing values in B as a starting point. It then refines this estimate by considering its relationship with feature A. Next, IterativeImputer tackles feature C. This is where the iterative nature becomes clear. Because C is dependent on B, IterativeImputer will use the already imputed values of B, improved from the initial mean guess, to produce a better estimate for C's missing values. This highlights the dependency. The values of feature B are influenced by feature A. This dependency is exploited by IterativeImputer during the imputation process. Similarly, feature C's values depend on those of feature B. This chain dependency emphasizes the iterative nature, improving the accuracy of imputation with each step. The whole process repeats, iterates. It starts with the mean values as initial guesses and continually refines these guesses, using improved estimations from the previous iteration of the process. This iterative improvement continues until a convergence criterion is met. After many iterations, IterativeImputer produces a completed dataset with no more missing values, all thanks to the power of iterative refinement.